All right, we are going to look at application questions of right triangles. And the hardest thing about application questions is you have to read the question and draw it. And you're going to struggle with that because you're going to want me to clarify things, and I will not. You're going to have to read the question. That's part of this. A group of campers has pitched a tent 250 feet from the base of a tall cliff. So here are the campers, and they are 250 feet from the base of a tall cliff, or 250 yards. So if you think about that, that has to be along the ground. If I'm going to measure that, I'm not measuring, I can't throw like a measuring tape from the ground up a tall cliff. Like it's going to be flat on the ground. The evening conversation turns into discussion of the cliff's height, and they all lodge an estimate of the angle of elevation. Okay, I'm just going to use this so you can see. The angle of elevation is from the standard position to the line. So they say the angle of elevation is 40. So that means that if I'm going up to the top of the tall cliff, so here's the cliff, they're saying that this angle of elevation is 40 degrees. So when I start at this bottom, I start on the standard position and I'm looking up, okay, that is the angle inside the triangle. Sometimes it's going to end up outside the triangle, but in this case, it's inside the triangle. And so you have to draw to see what's happening, okay? So if I want to look at this, it says how tall is the cliff? That would be this side. So from the 40, that's opposite, and I know the adjacent. So I'm going to use the trig function. The tangent of 40 equals x over 250. So I have my calculator again. So I would do 250 tangent of 40 on my calculator. And my answer is 209.77 yards. Okay. All right. So on the next one, from the edge of a glacier, Gary notices a kayak on the lake 30 meters below. So here is lake, here is the kayak, here is Gary up on top of the glacier, and he notices it 30 meters below. That is at a right angle. That's saying that this is 30 meters below where he is standing. Okay, so if I put this out, the height from Gary's to where the kayak is 30 meters because it's 30 meters below. Okay, so you've got to be very careful with that. It's not at an angle. If the angle of depression at that point, so angle of depression, I'm going to use a different color here. Angle of depression is the one going down is at 35. So that means from this angle, my angle of depression starts at the initial and it goes down. So that's 35 degrees. If you look, that 35 degrees is not inside this triangle. Okay. And so I want to know what is the distance from the glacier, which is right here, to the kayak, which is right here. I want to know this distance. Okay, so and you know it's along the perpendicular because it's easy to understand. Like I can't drop, like I said earlier, I can't drop a measuring stick to there, but I could go on the glacier, I could go into the water on the lake out that far. Okay, so the first thing I'm going to have to do is I'm going to have to do 90 minus 35, and I have no idea why I used my calculator, but I did. So this angle in here is 55 degrees. I want this distance, and I know the height is 30. So that's going to be the tangent of 55 equals x over 30. So I'm going to do 30 times the tangent of 55. And my answer is x is 42.84 meters. Okay. All right. So on the next one, from his hotel room window on the 6th floor. So he is not at the ground. He is on the 6th floor. Susie notices some window washers high above him on a hotel across the street. So these window washers are high above him across the street. There's the window washers. There's Susie. He quickly estimates the buildings are 50 feet apart. So no matter what, buildings are going to be 50 feet apart the whole way up. Curious as to height above the ground, he quickly estimates they're 50 feet apart. The angle of elevation, okay, the angle of elevation to the workers is about 80. So that means the angle of elevation from Susie to the workers is 80. So I have this triangle right here, and it has the 80. And I could find out how tall they are from there, because can't I say, if I'm standing there, can't I say the tangent of 80 equals x over 50? And so I'm going to do 50 times the tangent of 80. And my answer for x is 283.56. Okay, now I can do the exact same thing with the hotel room. So, and the angle of depression to the base of the hotel is 50. So the angle of depression to the base of the hotel is 50. This actually ends up being inside the triangle. So the tangent of 50 equals y over 50. So 50 times the tangent of 50 ends up being 59.59 meters. Okay, how about high above the ground is the window of Susie's hotel room? So wouldn't that be the 59.59 meters? How high above are the workers? So aren't you going to take that 59 plus that 283? And I got 343.15. Okay. Now, on the next ones, these get a little confusing. Okay, so these are going to take a little bit of thinking. So when you draw, you have to draw them. So this is north, south, this is west, east. You're starting on the north line. So put a dot on the north line, and you're going to the east 32 degrees. Okay, that's where that angle is at. That angle is actually inside here because it's going north to the east. Okay, and then if I look at the next one, I go north, south, west, east. And now I'm putting a dot on the south line, and I'm going to the west. So this angle would be 50 degrees because now I'm giving you the one on the inside. Okay, so you have to read these questions very carefully when they give it to you in, it's north, south, west, east, when it's directional angles. Okay, they are not necessarily like standard position. So, example 5. A city building requires a new shopping complex to be built at least 150 feet from the road that runs due east-west. So I am going to draw the road first. It runs due east-west. So this is the road. A surveyor finds the tip of a shopping complex lies closest to the road, about 100 or 200 feet away on a bearing northwest. So that means when the surveyor is looking, he's looking north to the west. So he is looking this direction. Okay, so the shopping mall is over here. And the closest point, so it says, if we read this, that the surveyor's angle, so right here, is 41 degrees, 17 minutes plus 15 seconds, is this angle is 41.2875. So if I draw this in, it says that it lays on that bearing 200 feet away. So I don't know why I wrote 5, sorry. So that means that these machines that surveyors have, they can measure how far this distance is and the angle. So if this is, but I'm looking at this triangle, and for me to keep my job, this side right here cannot be more than 150. I don't know what it is right now. Put a bunch of question marks. Okay. If it comes out as 150, I'm good. If it doesn't, I'm in big trouble. Okay, so if I do 90 minus 41.2875, I get 40, so this angle in here is 48.7125, and I'm doing opposite over whoa, that's the hypotenuse. Opposite over the hypotenuse is going to be sine. Good morning. Opposite is x, we don't know, but the hypotenuse is 200. So I'm going to do 200 sine of 48.7125. And before I hit enter, if this is the real world, if this is more than 150, I just lost my job. Because you can't be an architect that makes that kind of mistake, because it's not a legal building and now everything has to be redone. Oh, I got 150.28 feet. Okay, I just got fired, right? Because wait, it has to be more, at least. Ooh, I didn't get fired. I barely kept my job, at least. I had to read that. If it's closer than 150, then we're in trouble. So if that would have been like 149, but at 150.28, whew, I kept my job, okay? But that's what, as you're doing this, you're going to have computer programs and things that do the math for you, but you kind of have to understand the math going on or you're going to be in trouble, okay? All right, so go ahead and pause and try example 6. It's kind of similar to example 7 or 5. Just try it, see what you can get. If you can't get it, we're going to do it here in a second, but pause and try it. Okay, a large sign spans an east-west highway. So that means like I'm driving on an interstate. I don't even know, but it's a highway. So it has a bunch of lanes here. Like you're driving, imagine yourself driving in Denver on this highway. And you have a sign that goes from one side of the road to the other. Like you've seen those signs. They give you information. They tell you where the exits are, all of those nice little things. Okay, so from a point, so I'm going to read this. I've got the highway drawn. From a point 35 meters due west, so here's west, of the southern, here's southern. Every year kids are like, how am I supposed to know? You got to read it. So I'm going due west of the southern, and I'm going 35 meters. A surveyor goes, and he finds the bearing of this line. So he finds this line right here, okay? And he finds that it's on a bearing northeast. So that's outside of the triangle. So 11 divided by 60 plus 42 divided by 3,600 ends up being 0.195. So this angle is 67.195. So if I do 90 minus 67.195, my answer, this inside angle is 22.805, right? And I want to know how wide it is to the nearest centimeter. So if you think about that, meters, a full meter, a centimeter is 100th. So I just need to round it to the 100th place. That's what that's saying. It's saying round to the 100th. Right? Okay, so if I do this, I would do tangent. The tangent of 22.805 equals x over 35. So I'm going to do the tangent of 22.805 times by 35. And my answer, this sign is 14.72 meters. And it says round to the nearest 70 centimeter. Well, that's 14 meters, 72 centimeters, because it's going to be to the 100th. All right. So go ahead and read this next one. Okay. To catch a driver who has radar detection equipment, a state trooper hides 50 feet from the road. Using her sighting device, she finds her position and the road sign to be a distance of 79 degrees. So it's a sighting. The angle between is 79 degrees. She then uses a stopwatch to determine how long it would take a vehicle to pass her location and reach the road sign. Find the speed it takes if an 18-wheeler is going 2.7 And then what if a car takes 1.9? Okay, now anywhere in here, like on the last two questions, they said an east-west highway, an east-west road, blah, blah, blah. This one doesn't tell you that, so that's giving you the hint. It really doesn't matter how you draw it. Okay, so if I just say, I'm going to say like here, because we've been doing the roads this way, right? Okay, she hides 50 feet from the road. Below, above, it doesn't say, so I'm just going to put 50 feet, and that's from her to the road. Using her sighting device, she sees the angle between her position and the road sign. So we'll say the road sign is right here, but I could have put it the other way, is 79 degrees. Oops, 79 degrees. So this angle is 79 degrees. Okay, I could have made it the other way, but I guess the cars, they are going this way, and she's clicking start when they pass her and then seeing what the speed is. Okay. All right, so doing all that, the first thing, I can't even find the speed until I find this distance. So wouldn't that distance be the tangent of 79 equals x over 50? So I would do 50 times the tangent of 79, and my answer on that is 257.23 feet. Okay, so 257.23 feet. So then what you have to think about is, okay, how do I find speed? Speed is distance. So we're going to do this car first. The 18-wheel takes 2.7. Okay, the speed is distance, which is 257.23 feet, divided by time, in the 18-wheeler's case, is 2.7 seconds. So 257 divided by 2.7 ends up being 95.27 feet per second. Okay, but that's not in miles per hour. So in this class, you're going to have to do some conversion. So in a foot, I want to convert it to miles. In 1 mile, there's 5,280 feet. No, you don't have to memorize that. If somebody shouted out on a test how many feet are in a mile, I would tell you. But this cancels it. And then how many seconds are in an hour? 1 hour is 3,600 seconds, because then those seconds cancel. And I end up with 95 divided by 5,280, and then times that by 3,600. And the 18-wheeler is going 64.96 miles per hour. Okay? So probably not speeding if we're on a highway. All right, so now let's look at the car that passed in 1.9 seconds. Do I really have to start back over on this problem? Isn't this distance going to be the same? So now I'm going to take 257.23, and I'm going to divide by 1.9 seconds. So 257.23 divided by 1.9 equals 135.38 feet per second. So I want to convert feet, so I'm going to put those on the bottom, into miles. 1 mile is 5,280 feet, and I want to convert seconds, top, into hours. 1 hour is 3,600 seconds. So kids will start asking me, do I have to write this? It's the same. I don't really care. Your science teachers get mad at me if I don't make you write it. So don't go around saying Miss Williams doesn't make us write that, because then they're just going to come get mad at me. But your answer is 92.31 miles per hour. This person's probably getting a ticket. Okay?